Example 5 is on finding the derivative of a function. Again, this is one of those interactive examples, so if you're a visual learner, I highly encourage you to download the Wolfram CDF player, download this file right here, and then you open this inside the Wolfram CDF player to visually see what is going on. Okay, you don't have to do that to find the answer to the problem though. It says find the derivative with respect to t for the function y equals 2 over t. Okay, so this is going to look something like we did before. I'm going to go ahead and write the hint, but again, this is a really important problem. I'd star this problem because something like this and or the previous problem with the square root of x most certainly will be on your test. When you do this, you must use definition of derivative. You cannot use the rules if you know the rules, so you have to use the limit as h approaches 0 of f of x plus h minus f of x all over h. So if that's what we have to do, let's go ahead and start off by writing that. I'm going to write f prime of, and usually I write x, but now it has to be a t, right? So f prime of t would equal, this would be the limit as h approaches 0, f of t plus h minus f of t all over h. So we have to use it with t's now instead of x's, no difference. Every process is exactly the same. Again, you can either do this inline all at once, or you could do this step by step, breaking it into the 4 different steps there are. I do not care which work you show, just make sure you show work. I'm going to go ahead and do this inline. So this is the limit as h approaches 0 of, and I'm going to put my colors like I've been doing to help emphasize what it is. Okay, f of t plus h. So I go right into my problem, my function 2 over t, and wherever I see a t, I'm going to put in a t plus h. So this is going to be a 2 over, and that would be t plus h is what I'd have, right? So there's f of t plus h minus the original function, and the original function is quite simply 2 over t, and then all of this is over h. Again, let's see, can we just plug in h equals 0 right away? Well, if we plugged in h equals 0 right away, this would be 2 over t minus 2 over t, which would be 0, all over 0. That's the indeterminate form. We did a problem nearly identical to this in the previous chapter when we were evaluating limits. So again, the only new thing is that we're taking the limit as h approaches 0 instead of it being an x, but that's perfectly fine. Hopefully you remember from the previous test, from the previous sections, how to do this. So what's the trick on this one? You must find a common denominator. So that's the trick to the problem, is finding a common denominator, okay? So if we find a common denominator, what are we going to do? Well, again, in the algebra review section, the functions and line reviews, I told you this is a compound fraction where we have fractions over fractions. There's multiple ways we could do this. We could look at just the numerator first, or we can multiply every single term by the denominators. That's the trick that they do in the book, so that's what I'm going to do for you guys now, is I'm going to multiply everything times t and t plus h. So I'm going to multiply everything by t and t plus h. So if I multiply this by a t and a t plus h, I multiply this by a t and a t plus h, but I also have to do it on the bottom. Literally every single term needs to be multiplied by a t and a t plus h. Okay, what happens when we do that? When we do that, the t plus h's cancel in the first one, and I'm left with, well, this would be the limit as h approaches 0 of, in the first term, I just have a 2t left over, minus. Let's look in the second one, the t's are going to cancel. So what I'm going to do is I'm going to do a couple steps in one, so hopefully I don't lose you. I'm going to take the negative 2, and I'm going to distribute the negative 2 times the t, and then the negative 2 times the h. So what I'm actually getting is a minus 2t, sorry, let me use black, minus 2t, and then that negative 2 times the h would be minus 2h. This is all over h times t plus h. Okay? Again, you probably see two things happening here. You probably see certainly the 2t minus the 2t cancel. But you're probably going to try to cancel those or simplify those h's in the same step. You absolutely cannot do it in the same step. It absolutely has to be a separate step. So please, please, please make sure you do this in 2 steps because mathematically you cannot simplify them yet. This is the limit as h approaches 0. On top we'd have negative 2h all over h times t plus h. What happens? H is simplifying now and only now because they are factors of both the numerator and denominator. So I'm left with the limit as h approaches 0 of negative 2 times 1 is negative 2, and on bottom I have a t and a t plus h. Now that I've done all my simplification, let's check to see if I can plug in h equals 0. In other words, evaluate my limit. And again, at this point, I am evaluating this limit, so I don't have to write the limit anymore. So you've got to have your equal signs the whole way. You've got to have your limits the whole way until this step. Now it's negative 2 over t times t plus 0, which would be negative 2 over t squared. And there's our final answer. Sorry for the look of that negative 2 on top there. This is negative 2 over t squared. Okay, so the trick there was you must find a common denominator. So we multiplied everything, in this case, by t and t plus h, everything on the top and the bottom. Okay, so this is a step in Calc Chat when you were looking at the solutions to this that they really kind of brushed over this step. They didn't show multiplying and simplifying everything by t and t plus h on previous notes, so I wanted to really, really emphasize that step for you this time. Okay, so let's look at the next one, differentiability and continuity. So we already know what continuity is. Continuity means the function exists, the limit exists, and the function's equal to the limit value. It says the alternate limit form of a derivative shown below is useful in the investigation of the relationship between differentiability and continuity. The derivative of f at c is f prime of c equals the limit as x approaches c of f of x minus f of c all over x minus c, provided the limit exists. Okay, so what are they doing here? They're just finding the slope between these 2 points, cf of c and xf of x. Notice it's y2 minus y1 over x2 minus x1 is all they're doing there. And then they're taking the limit as x approaches c. So they're actually having x approach c instead of c approach x. So it's just a different version of the derivative, the alternate form of the derivative. Quite honestly, I virtually never use this form of the derivative. I always use the standard form of the derivative. But on some of the problems, you might want to try this to see what it looks like. Again, I don't use it.